All right, so now that we know what a titration is, now let's take a look at the math. And like I said in the video before, the math really isn't anything new. It's essentially stoichiometry and a very simplified version of it, in my opinion, because with a titration, you're not dealing with a limiting reactant so much as you are trying to figure out, hey, I'm reacting this much of reactant 1, how much of reactant 2 do I need for it to fully react? So it kind of eliminates that whole limiting reactant step. And so let's just take a look at some examples. So example 13, what volume of a 0.203 molar sodium hydroxide solution, is needed to neutralize 25.0 milliliters of a 0.188 molar sulfuric acid solution? All right, this sounds very similar to a dilution problem, but it is not a dilution problem. Please, please, please do not use M1 V1 equals M2 V2. I know, it's super tempting. Don't do it, okay? The only time you're going to use this formula is when it says, all right, you've got this molarity of a solution and you're adding water to dilute it, okay? If there is a chemical reaction happening, like here, you're reacting sodium hydroxide with sulfuric acid, neutralizing, that's a chemical reaction. You do not use M1V1 for that. Instead, you use stoichiometry. So what's the first thing you've got to do with stoichiometry? Remember, we need to write out a balanced chemical equation. So you have sodium hydroxide, NaOH, and you're reacting it with sulfuric acid, H2SO4. Okay, so this is an acid-base neutralization reaction, specifically, or not specifically, but it's double replacement. So the sodium and the hydrogen are going to switch spots. So at this point, I'm going to go a little faster just with the predicting the products. So sodium is now going to bond with the sulfate. Make sure that's written correctly. So we need 2 sulfates because sodium's +1, sulfate's -2. And then the other product is when hydrogen comes over here and bonds to hydroxide, which remember, when hydrogen bonds to hydroxide, that's going to be your water. And then we have to make sure that this is balanced. So we got to put a 2 here, and then we got to put a 2 there. So that way it's balanced. So now that we have that information, now let's write all these numbers underneath where they go. So what volume of base, sodium hydroxide, so what volume, and when we talk about volumes in lab, we typically are talking about milliliters. That's why it's got milliliters here. So what volume of base, knowing that its molarity is 0.203, is needed to fully react or neutralize 25 milliliters of, put a little point there, of a 0.188 molar solution. Notice I'm not asking anything about the products. Do you see that? The problem is not asking anything about sodium sulfate or water. It doesn't matter. The question is saying, all right, you've got 25 milliliters of the acid, therefore how much base is needed to fully react with it? Meaning no leftovers, no limiting reagent, no excess reagent, it's fully reacting. But it's stoichiometry nonetheless. So remember, with stoichiometry, after you have the balanced chemical equation, first thing you want to do, write down what is given to you and convert it to moles. Well, we've got a lot of stuff given to us, right? But the actual definitive amount that I have is this 25 milliliters. Molarities are never going to be what you start with. Molarities are a conversion factor. It says this is how many moles there are per liter of solution. This is helping us to convert things. This is not going to be what we start with. The 25 milliliters, that's the actual amount. So 25.0 milliliters is the amount of acid, and ultimately I'm going to use that to solve for my base, right? So there's my milliliters. Now I'm going to convert to moles by using the molarity for the acid. So I know that for every 1 liter of solution, which is the same thing as 1,000 milliliters, there is going to be 0.188 moles. So that'll get rid of my milliliters, and now I'm in moles. Okay, so that's step number 1. Step 2 of stoichiometry is I want to get out of moles of my H2SO4 and I want to get into moles of NaOH. That's what I'm asked to solve for, which is over here. So this is where my mole ratio comes into play. For every 2 moles of base, 1 mole of acid is needed. That comes from the coefficients that are out in front. And so my moles of acid will cancel, and now I'm in moles of base. But I don't want to know moles of base, I want to know milliliters. And so that's where I use this molarity for the base here. So there will be 0.203 moles. Notice that goes on the bottom, so that way it cancels. There will be 0.203 moles for every 1 liter of solution, or in other words, 1,000 milliliters of solution. All right, so now we've got our setup here. Real quickly, I just want to show you, once again, I was telling you, but this was step 1 of stoichiometry. This is step 2, and then this is step 3. Okay, so there's our stoichiometry steps. Mathematically, nothing new here. All right, but I'm going to do the math here. 25, let's say 25.0 times 0.188 times 2. Okay. With, looks like 3 significant figures is what my answer should be. My milliliters of base is 46.3 milliliters of NaOH. That is what is needed there. Okay, so that would be my answer for example 13. All right, let's look at example 14. So example 14, it's a little different, but same idea. It took 12.17 milliliters of barium hydroxide to fully neutralize 15 milliliters of hydrochloric acid, and the molarity is given here. Based on that, what's the molarity of the base? So this time I'm not asking for volume, I'm asking for molarity, but we're going to start this very similarly. First thing, I need to do a balanced chemical equation. Okay, so we have barium hydroxide is reacting with hydrochloric acid. Okay, so to predict my products, barium is now going to bond to the chlorine. There needs to be 2 chlorines, so that way this is written correctly. And then my second product is always going to be the water here. And to balance everything out, let's see, I need 2 there, and then I need a 2 there. So that was my balanced chemical equation. All right, so now I'm going to write the values that the problem gives me underneath. So let's see, it took 12.17 milliliters of the barium hydroxide to fully neutralize with 15 milliliters of the acid. And I do know the molarity for the acid, so it's 0.560 molar. The question is, based on that information, what's the molarity for the base? All right, so once again, it's not asking anything about the products, right? So it's just asking information between the reactants. So I have 2 amounts that I'm given over here, like 2 definitive amounts. I have the exact milliliters of base and I have the exact milliliters for the acid. But I'm going to start with the acid one because that's the one I know more information about. So I'm going to start out with 15 milliliters of the acid. And step 1 of stoichiometry, let's get that converted into moles. So the molarity is where we will do that. For every 1 liter or for every 1,000 milliliters, it will contain 0.560 moles of HCl. And that'll make my milliliters cancel. Okay, so that's step number 1. Step number 2, HCl. Step number 2, use my mole ratio. I want to convert out of moles of HCl, and I want to be in moles of the barium hydroxide. And according to my balanced chemical equation, for every 1 mole of barium hydroxide, I will need 2 moles of the acid. So moles of HCl will cancel, and now I'm in moles of barium hydroxide, and that's step number 2. Now I'm actually going to stop right here because I don't have a molarity, so I can't do step 3. So we're going to end this a little differently. There is actually a way you can set this up continuing on with your stoichiometry calculation, but I'm just going to stop right here and you're going to see what I'm doing in just a moment. So I'm going to do 15 milliliters times the molarity 0.560 divided by the 2 and the 1,000. And so right here at this step, I end up calculating that it is 0.0042 moles of the barium hydroxide. Okay, so it took that's essentially saying it took 0.0042 moles of barium hydroxide to fully neutralize the acid. Well, that number of moles is what's represented in 12.17 milliliters. And so that number of moles is in 12.17 milliliters, which is the same thing as 0.01217 liters. And the reason why I'm converting it to liters is because if that's how many moles are in that many liters, then taking those two numbers and dividing it, that's going to give me moles per liter, which what is that? That's molarity. And so 0.0042 divided by 0.01217, keeping, let's see, 3 sig figs because of the molarity, that ends up being 0.345, and then I could either write moles over liters, or I can just write a capital M. Okay, either one's fine. But that would be the molarity for the base. All right. And then finally, example 15. Example 15, this is actually something I'm going to do in another video. This would be kind of like a challenge question, or maybe even an extra credit. So because this one will just take us a little bit more time than what I'm left with, I'll just do that in one final video.